Hey everyone, and welcome back. In this one, we're going to have a look at some more advanced SQL topics, including how to join data from multiple tables, how to group data for better analysis, as well as how to use different functions to summarize and analyze our data too. Let's go ahead and get started. Alright, so here I am back inside of SQL Server Management Studio. So far, we've just been pulling data from a single table in our database. But what if we wanted to look at and pull data from multiple different tables? If we take a look at the data in our sales.sales territory table, we can see that the company operates in quite a few different territories across multiple countries. But in and of itself, this table doesn't provide too much information about any of these territories. For instance, what year the company started operating there, or which salespeople we have operating in these regions. What we do have though is a territory ID column. If we check our list of columns in this table, we'll see that this particular column is designated as a PK, or primary key column. Primary key is a term that we covered in the first lecture of this section, but just to recap, its purpose is basically just to uniquely identify each row within a table. For our example, let's say that the company wants to have a look at how it's performing in each territory. It would be helpful to see when the company first started operating there too. But the issue here is that this information is currently housed in a completely different table, which happens to be the sales territory history table. So in order to get all of these results together, we'll need to join these two tables together. Let's quickly take a look at the data in our sales territory history table, and a helpful trick, instead of writing out a select query each time we need to pull data, we can just right-click on the table from Object Explorer and click on Select Top 1000 Rows, which will automatically write out the select query for us, with all of the columns and first 1000 rows inside of that table. We can see that in here, we've got information on the start and end date, along with a bit of information here at the end. But more importantly, for our join, we've also got the same territory ID column, and this is what we'll use to join our two tables together. I'm going to go ahead and create a new query, which I'll do by pressing Ctrl+N as the shortcut, and then we'll work through this step by step. I'll start out by selecting the columns, which will be the territory ID, name, country region code, group, sales YTD, and sales last year, which will be from our sales territory table. And also note here that I've used square brackets to select the group column. The reason for this is that group is a reserved keyword in Microsoft SQL Server, so we'll need to wrap it in square brackets just to indicate that we want to actually retrieve the table and not call group. Let's just put our from statement in, and I've just noticed here that I've put an extra comma in after we selected our sales YTD column, so I'll just go ahead and remove that. And this then is just all of the data that I want from our sales territory table. You might be wondering why I've put each column on its own line, and the main reason for this is just that it makes our code a little easier to read, and also it's considered general best practice. Okay, so this is all working fine so far, and we're pulling all of the data from this table, but as we mentioned earlier, we also want to select the start date and end date from our sales territory history table. If I try and select these two columns now by putting the start and end date in our select statement, and then run this, we'll get an error telling us that we have invalid column names. And the reason for this is because currently we're only selecting data from the sales territory table, of which these two columns don't exist in here. Instead, they exist in the sales territory history table. So in order to select these columns, we'll need to connect or join these two tables together. We're joining our sales territory and sales territory history columns together, and we know that in each of these tables there's a key column called territory ID. So that's going to be the column that will join our two tables on. At the bottom here, I'll type in join and then sales territory history. So we've now joined our two tables together, but we'll then need to specify which column that we want to join them on. And this will be the territory ID column, as we've discussed. So I'll say on, and then the sales.sales territory table, and the territory ID column, which is just referring to this column here. We're joining this table on the territory ID column from our history table, so I'll say equal to, and now the territory ID from our sales territory history column instead. And also, before we run this, we'll need to change the territory ID in our select statement and specify which table that we want to select this column from, as currently this statement is ambiguous because SQL is seeing two possible versions of this that we could select. I'll just specify this to pull it from the sales territory table, like so. Nice one. If we run this now, we'll see that we get all of the information that we had before, but now at the end, we've also got the start date and end date columns. The start date is when we started operating in that territory. Both of these columns are coming from our sales territory history table. We've got some null values in our end date column, and these are for territories where we're still operating, and there of course isn't an end date. So now that we've joined our tables together, let's have a look at how to tidy our query up a little bit. To do this, we could use aliases. Instead of saying sales.sales territory, we could abbreviate this as ST, which is just short for sales territory, and then STH for our sales territory history. And now we can replace these long table names simply with the aliases instead, which is much quicker and easier to read. Let's now take this a step further and then add in the name of the salesperson that's responsible for that territory too. This might be a bit confusing at first, but as we work through it, it'll start to make sense. Currently, we've got our territory sales and territory sales history table joined together, which gives us access to all of the columns in these tables from within our query. One of the columns in our sales territory history table is the business entity ID, which is another key column. And basically, this is just a unique identifier for anyone that's either working for or that's related to the business. If we check the contents of our person.person table, we'll see that we also have this same business entity ID column in here too, along with some information relating to the names of these people. So in the same way that we joined these two tables on the territory ID, we'll now join our sales territory history and person tables on the business entity ID. I'll go onto a new line and say join, but this time we'll join the person.person table as PP, which to be honest probably isn't the best alias, but it does go with the convention that we've been using so far of abbreviating the first character of each word. So I'm just going to go ahead and use it. We'll join this on the business entity ID column from our sales territory history table, which had an alias of STH, which is much easier to say, And finally, this column will be equal to the business entity ID in our person table, like so. Now that we've joined our person table to the sales territory history, we can just add in the first name and last name to our select statement. Okay, and great job. This query is now pulling data from 3 different tables: our sales territory and sales territory history tables, as well as the person table too, which is providing us with all of this data here. Before we move on, I'd also just like to go back to the topic of joins, which is something that we covered earlier on in the course in our section on pandas. Like pandas, SQL also uses an inner join by default. If we have a quick look back at this slide from before, this shows and explains all of the different types of join that we can make, along with a description of what they do. Inner join will be the most common type of join that you'll use, and all an inner join does is return all of the rows where there's a match in both tables. The reason that this is most common is that if you use a different type of join, you might find that you get null values, where it's returning data without a match. If you'd like to read through all of these again, then just feel free to pause the video and have a read through. Back in SQL, I'll quickly demonstrate what changing the type of join will do to our results. Currently, both of these are using an inner join because, as I mentioned, SQL uses an inner join by default. But if I change our last join to be a right join, then we'll see that we get a whole load more rows, but also with a load of null values for the sales territory columns, but then with the names filled in. This is because a right join returns all the rows from the right table, which in this case is our person table, which contains our names, and then the matching rows from the left table. So if we scroll down here, we'll see a few rows that do contain information about the sales territory, which we can see we do have one here. But I'm just going to undo this, as we're only really interested in returning data for the matching rows, so that we can see the name of each salesperson. Okay, so with that done, I'd now like to move on and show you another couple of helpful tips and commands that we can use in SQL. Currently, all of our return data is unordered. There may be times when we want to order this data so that it's easier to analyze. The command that we use to do this is order by. At the end of our query, I'll just type in order by, and then after this, that we want to order or sort it by. We can sort our data in alphabetical order, numeric order, or even in date order. If I say order by territory ID, as this column is numeric, it will sort our data numerically in ascending order by the territory ID column, starting with 1 and then finishing at 10. To sort it in descending order, we could pass in desk or DESC at the end of our order by, which is just short for descending. And this time, our ID now starts at 10 and finishes at 1. As mentioned, it's also possible to sort alphabetically, which I'll show with the name column. And finally, in date order, which I'll do with the start date. So now, we've got all of our territories in the order that we started operating there. There's just 2 more topics that I'd like to go over in this lecture, which are functions and grouping data. Let's start with functions. SQL provides us with access to a number of different functions that are similar to those we had in Python and Excel. there's two main types to be aware of. Scalar functions, which operate on a single value, and aggregate functions, which operate on a set of values and then return a single aggregated result. Aggregate functions are usually used when grouping data, so we'll have a look at these next. To start, I'd like to show you a couple of string functions. The three most commonly used of these are concat, which adds two strings together and is one that we're familiar with from Excel and Python, and then upper and lower, which again we've used before. Starting with concat, let's use it to add our first name and last name columns together to return a full name. At the end of our select statement, instead of choosing an existing column, I'll actually call the concat function, and inside of our parentheses, I'll pass in the first name column, a comma, and then our last name column. To give this column a name, I'll also add in an alias, which I'll set as a full name. So now we've got a full name column at the end of our query, which is the concatenation of the first and last names. We'll need to add in a space between each of these, so I'll go back to our concat function and add in another comma, a set of quotes, and then a space in between here. Then we've got upper and lower, which will just return a string in either all upper or all lowercase respectively. To demonstrate these, I'll call upper on our name column and lower on our country region code, which are currently in title case and uppercase respectively. And there we go. This is a very easy way to change the casing of a text-based column, but I'm just going to go ahead and undo these. Okay, so let's now use the round function, which we can use to round numeric columns. Currently, our sales columns are rounded to 4 levels of decimal point, but I'd like them rounded to 2 decimal points. In our select statement, I'll go to our first sales column, which is for the sales YTD, and then before this, I'll add in the round function. This function takes in 2 arguments. First off, the number that it's rounding, and then the other argument is the number of decimal places that we want, which we wanted as 2. And then I'm just going to go through and repeat this for our sales last year column. Calling functions on these will reset their column names, so if we run this, we'll see that it's now got no column name. I'll just go back and add in an alias for what the column was called previously, which we can just copy and paste. Okay, and let's now finally use the dateDiff function to calculate the number of days that the company has been operating in each territory. dateDiff is used to calculate the difference between 2 dates, and will return the result in a specified format, such as years, months, days, hours, minutes, and so on. Just after our end date column, I'll create a new column using the dateDiff function, and this function needs 3 arguments. Firstly is the interval or date part, which is the format that we want to return the difference in, and this is where we can choose either years and months or so on, but I'll go ahead and choose days. The next 2 arguments are then the start date and end date. I'll set our start date to be the start date column and the end date to be the end date column. And finally, I'll also set an alias of days difference. This function has now created a completely new column which shows us the difference between our start and end date for each territory, with a null value for any territories that don't have an end date. And finally, before we finish this lecture, let's have a look at aggregate functions and grouping in SQL. Aggregate functions work the same way in SQL as they did in Python. They just take in a set of values, perform an aggregation on them, and return a single value. There are 5 aggregate functions in SQL to be aware of, and these are the count, sum, average, min, and max. And we've covered all of these aggregate functions throughout the course, so we should be familiar with what all of these do. Let's start out by saying that we want to have a look at the sum for all of our year-to-date sales. What I'll do is create a completely new query below our main query and select the sales YTD column from our sales.sales territory table. When I run this though, instead of just pressing F5, which will execute the entire query, I'll select our new query and then press F5. And this way, we'll only run the selected query. And this query then returns 10 different rows for each of the year-to-date sales for each territory. To look at the total sum for our year-to-date sales, we could just wrap our sales YTD column in the sum aggregate function like this. And that will then just return a single aggregated sum, which has come out at just a little over 52 million. We could also view the count, maximum or minimum, or the average of these sales too. Let's say though that instead of just getting these values for the entire table, we'd actually like to look at these values but grouped by the country region code. At the end of our query, I'll just say group by and then pass in our country region code like so. And now when we run this, we get the average value of our year-to-date sales, but this time for each country code. To see what these codes are, we can then just select the country region column 2. All of the other stuff we've looked at, like filtering with where, would also work here too. Okay, really good job with this. It's been quite a long one, so let's leave it here. We have covered quite a lot of content here, such as joining tables, grouping data, and also some different functions that we can use too. So if you've got any questions or any problems with any of this, then please post it down below. In the next lecture, we're going to take a look at how we can take our data that's currently in our SQL database and then get it into either Excel or Python, ready for analyzing or cleaning. Thanks everyone, and I'll see you all in the next lecture.